Hello and welcome. If you are attending this talk, you're probably excited about the flexibility of the MongoDB schema, but also maybe a little worried that it might create burden for your application code. My name is Katya Kameneva. I'm a product manager here at MongoDB on the query team. And today I'd like to show you the tools that are available to you in MongoDB for achieving confidence in the integrity of your data and hopefully alleviate some of the concerns that you may have. So MongoDB has a flexible schema. Documents in the same collection can be of different shapes. Enforcing schema means locking down the structure of the data and preventing entries that do not conform to the specified constraints. Do you really need to enforce schema? Imagine you are creating a new app. There is a lot of brainstorming and rapid prototyping. You're experimenting with a data model, trying to design for good performance and ease of use. Putting rigid constraints on the data in your collection at this stage might be counterproductive. It can make it harder to iterate on your application and probably will be a wasted effort, since things change all the time. You may find that not enforcing a schema also works when your application is in production, as long as your architecture is not overly complicated and there is good communication within the team. Then, as your team grows, the product matures, you develop more services, there are more integrations, and your data has to conform to the format that is expected by all of the other systems that consume it. Now it may be a good idea to enforce important constraints for the data. For example, let's say you maintain a product catalog with the latest price information, and you are storing price value as a decimal type. Then there is a separate small service that scans other retailers' prices and injects that additional data for each product. The tool is working with multiple APIs, and sometimes it writes price from the competitors as double. Your main application can handle that. But now the product pricing team decided to track trends, compare prices, and build some useful reports. What they found out is that the tools that they're using for analytics don't handle this mix of types out of the box. This kind of problem can be prevented by enforcing schema and ensuring the consistent types. So how can you enforce schema? If you are using an object data modeling library, or ODM for short, you are already describing the schema during the definition of the model, specifying the types of fields, which ones are required, and maybe the range of accepted values. Often, as a default behavior, the tool will validate the document against its schema before inserting it into the database. But why this may not be enough? Because there is safety only in one input source. There are no other services. If there are other services that can write to the database or scripts that perform updates, you may need to have checks in place for those too. So a good practice is, once you have agreed on the schema, set up the validation for documents in the database on the database side, so that checks will be performed on every write, regardless of the source, including when someone connects to the database directly. Let's see how schema validation works in MongoDB. As an example, I will use collection of sales with sample document like this one. We have a sale date, a list of items that was sold, store location, and information about the customer, some other fields. As a first step, we usually want to ensure the correct types of values. For example, make sure there are no strings where we expect number or date. To set up the validation rules for collection, you can use interface of MongoDB Compass or provide the validation options to the create collection or call mod command in the shell. I will use Compass. Here is a validation tab where we can edit the rules. To express the rule, you can use JSON schema or MongoDB query language. I will start with JSON schema. JSON schema is great. It is widely used for validating API responses and has good community support. And we see that it is the most popular way to create validation rules in MongoDB. So here in Compass, this input box accepts a validator, which is a query filter that will be applied to the documents as they are inserted or updated. To use JSON schema, we use a $JSON schema keyword and specify a list of the fields inside of the properties object. To check for a type, we are using bson type. This is one thing that is different from the standard JSON schema specification, as we need to operate with the types that are supported by the MongoDB database. Now, let's see what happens if I try to insert the document that contains a field of the wrong type. I will insert the document with one field, sale date, and I will put a string value there. This document was not inserted. Here you can also see the improvement to the error message that was added in the MongoDB 5.0. The message now contains information about which field failed the validation and why it did not match the schema. This significantly improves the ease of use of schema validation, as when you have complex documents, without this information, it may require a lot of effort to isolate the components that cause the error. Another popular use case would be to set up the required fields for the documents. This is very easy to do by including the keyword required to the JSON schema specification. Let's add line items as required fields. Now, if we try to insert the document with no line items, we should get an error. And yes, we did. We see that line items is a missing property. And the check will also be performed on the update command. Let me try to remove the required field from one of the existing documents. You can do it with update1 and $unset of line items. Yes, it works. Now, when we talk about enforcing schema, this does not mean that once you do it, all the documents will have to be of absolutely identical structure. You can leverage the flexibility of the document model and still apply constraints. Say, in your customer's directory, a document representing a frequent shopper will have much more information than a document for a customer who just made the first purchase. When the documents of the same collection are different, you may decide to only lock down the critical fields and allow any additional fields. Or you can describe all available options for the document structure and not accept anything outside of that. Let's look. For example, when we fulfill online orders, we store shipping address of the customer. And if we serve customers across different countries, the format of the address might be different. Like here, address in the United States has state and numeric zip code, and in the UK address, there is no state, and postal code has a specific format. If we were looking at the individual JSON schemas for these two formats, we could have a rule like this one for USA and another one for the UK addresses. For combining schemas, there are some convenient features like one-off keyword in JSON schema. It lets us include all possible schemas in the array to express that the shipping address can take one of the specified shapes. Also, we included additional properties false. This prohibits the shipping address subdocument to have any additional fields from the ones we specified in the properties. A small tip for using additional properties false. Please note that it refers to the properties object and does not consider keywords like required. Do not forget to add all possible fields in the properties list, including _ID. For example, the rule like this is contradicting and incorrect. On one hand, it requires documents to have _ID and store location, but additional properties false indicate that the document can only have store location field. Adding all the required fields into the properties will fix the problem. Now, when we are talking about optional and required fields, I think it's also important to understand how the null values are treated. In JSON schema, null is considered to be an existing field. So if you need to disallow nulls, you should indicate the correct type of the field in your validator. And if null is accepted, you can provide it as one of the accepted types. Also, JSON schema offers convenient functions for working with nested fields and arrays. In our example of sales, field line items is an array of objects. To describe properties of the individual array elements, we use items keyword, and inside of items and min items, or verifying that all the elements of the array are unique. Now we talked about JSON schema. Let's talk about MongoDB query language. It is an alternative that you can use to express the rules for validating documents. In the end, the validator that you are constructing is just a filter. So everything that is available for filtering documents in the find command or $match stage of the aggregation framework can be used here. For example, we can add check to ensure that the discounted price of the sold products is less than the regular price. And we can do so much more, like ensure that if a coupon is used, there is no individual discount applied, or verify that the computed fields like subtotal and total were calculated correctly. You will probably find MQL most useful for expressing the business logic for the values, and JSON schema to be very convenient for describing the structure of the document. And actually, you can get the best of both worlds by combining MQL and JSON schema, just as you would combine two filter criteria in the query. You can put $ent in the beginning, and inside of it, two or more sets of rules for your schema. Now, let's talk briefly about versioning of the schema. As your application evolves, so does the data structure. Imagine that you used to only store the email of the customer, and now you want to keep their name and more contact options, and also make email or phone required. Before you have migrated existing records to the new format, you still want to have the ability to read and update the entries in the old format. One of the approaches that you can take is to introduce a version of the schema. The old documents are marked with version 1 and new documents with version 2. Your application code will have to have different logic based on the version that it sees. And as for the validation, you can express it as a choice between two schemas. For example, like this, using $or and listing two schema alternatives inside. You could also apply one of the built-in features of JSON schema for combining schemas, similar to what we used before for different formats of the address. Though this approach is more straightforward if you have many variations across schemas and will be less error-prone to remove the old schema from the options once it is not needed anymore. If you're planning to migrate all documents to the new schema pretty quickly, you can just set the new validation rules in place, but make the validation less strict. Validation level moderate allows to skip checks during updates of the existing documents that do not comply to the current schema. And all the new inserts still will be validated against the new schema, as well as the updates to the existing documents that already comply to the new schema. After you complete the migration of the data to the new format, you can switch back to the validation level strict. And at the time when you know there are older invalid documents present in the collection, you likely want to inspect them. You can find existing documents that do not match the schema if you run a query with $nor and provide a validator as part of the query. $nor returns all the documents that do not match one of the filters provided in the array, and here a validator will be the only filter. Alright, now since you may be familiar with relational databases, I'd like to touch on the differences between check constraints in relational databases and schema validation in MongoDB. In both relational databases and MongoDB, you can have optional and required fields. You can set constraints for values and express dependencies between fields within the same entry. Naturally, in MongoDB, you have more options for expressing variability of the schema, like combining schema, allowing multiple types, or even providing rules for the names of the fields. Currently, schema validation in MongoDB does not have a feature for setting values by the default. And of course, in the relational databases, there are foreign keys that are not present in the MongoDB. So I'd like to stop here just for a moment. Foreign keys are necessary to maintain referential integrity in the model that split up data and relationships across different tables. With the MongoDB's document model, referential integrity is achieved by representing relationships with subdocuments and arrays, thus removing the need for foreign keys and extra checks across entries that can potentially slow down the writes. There is another use of foreign keys, which is referencing some dictionary of the allowed values, like all possible statuses of the order or a list of country names. And these types of checks can be done with schema validation by enumerating acceptable values for the specific field. And here are a few final notes on schema validation in MongoDB. It operates on a single document. If you need to enforce uniqueness on the field across multiple documents, you will need to use unique index. Currently, MongoDB supports Draft 4 specification for JSON schema. And finally, reasonable schema validation does not have noticeable performance impact on the write operations. And this was everything that I wanted to cover today. I hope that now you know about the available tools for enforcing schema in MongoDB, and you feel confident that you can set up the validation that will work for you. Thank you for attending this session, and I will be happy to answer your questions.